Okay, so this is the second week of organic nomenclature, and we are going to be adding double and triple bonds to the naming of things. So remember, if you have nothing but single bonds, then your organic compound is going to end in ANE. If you have double bonds, at least one double bond, then it's going to end in ENE. And if you have triple bonds, it's going to end in YNE. Now, this assumes that it doesn't have any sort of substituents on there. We will be getting into those, don't worry. Now, another thing to keep in mind is that our double and triple bonds also end up with di, tri, tetra, etc. prefixes when there's more than one. Until we start putting substituents on there, then we still only focus on finding the longest chain, then the chain with the most side chains, and so on. There are one or two complications that get added on top of that, and we'll get to those in just a little bit. So first, let's go ahead and look at some simple double bond molecules. So nice unbranched alkane with alkene, 3, 4, 5, 6 carbons, and a single double bond. I've numbered this incorrectly. Some of you might have noticed that right away, because the only thing of note on this molecule is the double bond, so we have to number it from this direction. So with 6 carbons, it's going to be a hex molecule. And after the hex, we indicate where on the molecule the double bond is. We do so by talking about the carbon it comes from, not the carbon it goes to, because it's between two carbons, so you have to talk about at least one of those. So it's the carbon it comes from, so it's hex 1-ene. Fairly straightforward. Now let's do Now, once upon a time, the rules would have been to find the longest possible chain that included as many side chains as possible. As many double bonds as possible. Okay. They have since discarded that rule, but if you have an older colleague or coworker, then they might still be stuck in a rut when it comes to this sort of thinking. But we will just look at the longest possible molecule, and that would be going from this end over here on the left to 1, 2, 3, 4, 5, 6 up here to 1, 2, 3, 4, 5, 6 to 1, 2, 3, 4, 5, 6, 7. So it's going to be coming to this end down here. So these two up here are going to be side chains. Now let's go ahead and clear off some room, get things a little bit tidier so we don't have to worry quite so much about where we write things. Now, this is rather straightforwardly a methyl group. This has 1, 2 carbons, so it's an ethene group. Okay, ene to indicate that there's a double bond, YL because it's a side chain. We don't need to worry about indicating where the double bond is on that etheneal because there's only the 2 carbons. There's only one possible location for it. Okay. And then we're also going to have to find a way to indicate that it has 2 double bonds. That is actually quite easy. As for numbering, we have 1, 2, 3, 4 from the right for the etheneal, and 1, 2, 3, 4 from the left for etheneal. So etheneal doesn't help us decide which way to number it. So we're going to be numbering from the right because the methyl group is closer. Numbering the double bonds, that can have an effect, just as with anything else. It will almost never happen because they come, as you see, at the end of the molecule here. And you decide on numbering, left to right or right to left, based on the first time you see a difference between two possible numbering systems. So it is possible for the numbering of the double bond to make a difference in that way, even with other things, side chains and so on. But it's rare, just because it comes at the end. All right, so we're numbering from here. 1, 2, 3, 4, 5, 6, 7. So our molecule here is a 4 ethynyl, 3 methyl, hepta from, so 1, 5, dang it, I ran out of room. Diene. Remember, it gets a prefix, and there are 2 double bonds in the main chain, so di, and then double bond ene, so diene. So it's a heptadiene with side chains on it. The double bonds are between 1 and 2, so 1, and 5 and 6, so 5. Now, another complication to look at is when you have something like this. Now, as I said, once upon a time, it would have been a requirement to include that as part of the main chain. So this guy over here would have been a side chain, making this a 1, 2, 3, 4 ethyl butene. But that's no longer how we do it. So it's not an ethyl butene, and that's not a side chain. So nowadays, this guy up here is the main chain, okay, and it has 5 carbons, and it has a side chain right here, and it has a double bond in between the main chain and the carbon of the side chain. So the way we name that is meth, because there's only the 1 carbon right there. Il, because of the side chain. Idene. Okay. When there's a double bond in between the side chain and the main chain, it's an illidene rather than just an il. Okay. So it's on the 1, 2, 3 third carbon, so 3-methylidene pentane. That is how you name a side chain that's attached via a double bond to the main chain. It doesn't really matter how long that side chain is. You could have some really, really long molecule with something like this. So it could be a 23 hexylidene syntane. Okay, I kind of made that one up. I don't know what the number is, the prefix is for when you have 100 carbons on a main chain. Point is, any length can be possible for a side chain. Just this right here, the illidene tells you it's attached via a double bond. All right, triple bonds are treated pretty much the exact same way, except that they end in Y in E, and they're pronounced ein. So this right here, B but 1 ine. It's a butine. You will occasionally see something like that written like this. 1 butine. Sorry, that typo with a pen. All right, 1 butine. That's the older way, the pre-2013 way. But that is less clear. You can have multiple things attached after the main compound, like double bonds and triple bonds, and some other subgroup. So they no longer do it like that. They prefer it to be in between the number of carbons on the main chain and whatever it is that comes at the end there. So but1-ine right there. Now let's go ahead and give an example like this. Okay. A triple bond in between the main chain and the side chain. That can never happen. That is just physically impossible, because carbon only forms 4 bonds. And this right here has 1, 2, 3, 4, 5 bonds coming off of that carbon. So it's just not possible to have a triple bond going off to a side chain. You never have to worry about that. Instead, you have to worry about something like this. If you have multiple double and triple bonds on a single chain. Okay. I've left it unbranched just because I wanted to be absolutely certain that it was physically possible and nameable in a reasonable amount of time. But we have 1, 2, 3, 4, 5, 6 carbons. So it's going to have hex right there in the middle. There are no side chains, so nothing goes in front. All that's going to come after is the double bonds and the triple bonds. So hexa. Now, what comes first? Double bonds or triple bonds? Well, just like everything else, it's in alphabetical order. Ine, then ine. Okay. It's also handy that means that double bonds come before triple bonds. I mean, it's just maybe perhaps a little bit more intuitive that way. But we number this. The first place that you would have a difference would be right here. It's the only place. So 1, 2, 3, 4, 5, 6. So that would make it 1, 2, 3 triene versus 1, 2, 3, 4, 5, 6. It would be 3, 4, 5 triene. So 1, 2, 3 is lower than 3, 4, 5, so the 1, 2, 3 version is correct. Now, just to give myself a little bit more room, I'm going to shift this over to the left. And what comes next is going to be the triple bond. And I made a mistake. This should just be triene without the terminal E, because that's just the way we do it. And then, so triene, what did it have there? I should not try to think on the go with these. I'm going to leave the E on there, and hopefully I won't have to correct myself. But then 5-ine. All right. So this is a hexa 1, 2, 3 triene 5-ine. Now, is it physically possible? Yes. As you look at, say, carbon number 4, it has 1, 2, 3 bonds to carbons and an invisible hydrogen. Carbon number 3 has a double bond to its left, a double bond to its right, for a total of 4 bonds. Same for carbon 2. It has double bond to the left, double bond to right, for a total of 4. Carbon 5 has 1 to the left, 4 to the right, 1 to the left, 3 to the right, making a total of 4 bonds. So, yes, this molecule is entirely possible, and it would actually be fairly easy to draw in the hydrogens, because there's 1 here, there's 1 there, and 1, 2 over on this end. This carbon chain has far fewer hydrogens. That is why carbon molecules, organic compounds that have multiple bonds in them, double or triple bonds, are often called unsaturated. Okay, that the alternative would be saturated, which would be saturated with hydrogen atoms, nothing but single bonds. Okay, because every time you put a double bond or a triple bond onto an organic compound, you are necessarily removing carbon-hydrogen bonds in order to do so. Yes, that is what they're talking about when they talk about unsaturated or polyunsaturated fats and things like that. They have double or triple bonds in them, usually double bonds. Triple bonds are not impossible in organic molecules, but they can be fairly rare. They're high energy. They're very energy dense. Okay. Now, other than the complication of having to put "-ine" and "-ine" at the end, there's not really much change from last week, the previous organic nomenclature video, sorry. You just find the longest chain, and you name it accordingly, and you stick your the double and triple bond nomenclature on the end of the molecule. So the longest chain here is going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. All right. So we're going from this end up here to this end down there. And it has 9 carbons for non as the main chain. All right, that makes this a side chain and this a side chain. All right, we have 1, 2, 3 carbons in that side chain. It has a double bond in between the main chain and the side chain, so that is propylidene. You know, I'll admit it's handy that this example works out like that, but I didn't intend it that way. This carbon, or this molecule, likewise has 1, 2, 3 carbons in it, which means it's going to be a prop. The double bond in there is not located between the main chain and the side chain. So instead of being a propylidene, it would be a propene-il. And because it's not attached at the end of the side chain, it is instead attached at the middle from the second carbon. You have to indicate that. And then you indicate that the double bond goes from the first to the second carbon in that chain by putting a 1 there. So it's a prop1 into il. Not too pretty, but what are you going to do? So we have propylidene and prop1 into il. Now we have to come up with the numbering for this chain. Is it going to be 1 to 9, or is it going to be 1 to 9? Well, let's see, 1, 2, 3, 4, 5, 6 versus 5 and 6. Which means what matters is what comes first, propylidene or prop1 into il. Letters come before numbers, so propylidene comes first. Okay. So that means that we give priority, or yeah, sort of priority. We're going to use the blue numbering system. 2, 3, 4, 5, 6, 7, 8. We are not going to be using the green numbering system. Let me just go ahead and mostly erase those numbers really quick so they don't get in the way. Okay, so that means we are looking at a 5. There we go. 5 propylidene, 6 prop 1, 2, prop 1 in no e, 2 il, nona, 2 in 8 ine. Because the double bond up here goes from 2 to 3, And the triple bond right over there goes from 8 to 9. All right. So, remember, for the moment, the notes, our organic nomenclature starts with finding the longest possible chain, regardless of what sort of side chains or double or triple bonds you are looking at. Here's something I know I haven't covered so far. Let's go ahead and look at one last example, fairly simple, hopefully. Nope. There we go. Now I know that that's a side chain. Okay, so this right here is our longest possible chain. That's our main chain, and it has 1, 2, 3, 4, 5, 6, 7. So it is heptane. What matters now is to find the name of the side chain. And that side chain has 1, 2 carbons, so it is an eth-ine ill. Okay. So this is 4-ethynyl heptane. All right. And that, I think, covers all of the possibilities you are likely to encounter for a branched alkene or alkyne without any sort of substitutes. Have a pleasant day.